All right, hi everybody. We're going to move into 5.3, and 5.3 is the elimination method of solving the system. Now here's the objective of the elimination method. Like the title says, we want to eliminate a variable from the entire system by adding both equations together. So the function that's going to get done to eliminate a variable from a system is adding both equations together. Now we're going to come down to the middle of this sheet of paper, and I've got written over here on the left-hand side a property that we're going to have to apply in order to eliminate a variable from a system. It's called the addition property of equality. And over on the other side is going to be the first system that we're going to solve using elimination. I have these two side by side so that I can sort of correspond different things as we discuss this property. So here we go. The addition property says if expression A is equal to expression B, come over here. This equation number 1, your x minus y is expression A, and it's equal to 4, which is your expression B. Let's continue on. And expression C is equal to D. This expression for equation number 2 that's on the left is your C, and it's equal to 8, which is your D. So if A is equal to B and C is equal to D, the addition property says I can take expression A and add it to expression C just as long as I come over to the other side and add expression B with D. I can also subtract C from A just as long as we subtract D from B. So this addition property gives us the right to do the following to this system. We can take expression A and add it with expression C just as long as we add B with D. But people, the only way I want to bring down a line and add this expression with the expression below it, and likewise on the other side, I only want to add if it's going to meet my objective. And meeting my objective is, I'm going to add just as long as I can eliminate a variable. So let's look at this system right here. I'd like you to take a look at the coefficients of y. This is a negative 1y, and this is a positive 1y. If we draw a line, and we add A with C, the y's are going to cancel out. And when we add the 1x with the 4x, that's going to leave us 1x with the 3x. That's going to leave us with 4x. They're gone. And it'll be equal to the sum of these two, adding your B with your D, and that'll be 12. What happened? We were able to eliminate a variable. What caused this variable to be eliminated? You need to make sure that we have this. The variable that's going to get eliminated has to have coefficients that are opposite in sign. He's a negative 1y, he's a positive 1y. That is the goal of being able to use the elimination method and then to add the equations. So in a moment, we're going to do this same system over here on the other side of that board. But before we get to that, one last remark. Before you can use the elimination method, there's a key prerequisite. And that prerequisite is both equations must be written in standard form. That is a must. They have to be written in standard form. They're in standard form. Standard form, like we know, is AX plus BY is equal to C. There's only one little thing that we just want to say. Ordinarily in standard form, the coefficient of x has to be positive. Not so when we're using elimination. You don't have to worry about the fact that the coefficient of x is positive. What we need to be concerned about is the x and the y terms must be on the same side and the constant must be on the other. And we certainly have that there for that one. Now I'm going to move over to that board and we're going to show you number 1 and we're going to use elimination. The elimination method is also called the addition method because to eliminate a variable from a system, we have to add the equations together. So look again at number 1. Both equations are in standard form. Look at the coefficients of y. The coefficients of x are not opposite, but the coefficients of y are opposites right now. So we can draw a line, and that's how the process begins. We draw a line, and we're going to add. We're going to add expression A with expression C. So we're going to add 1x added to 3x, 4x. A negative 1y added with a positive 1y, they cancel. So the y's are eliminated. Add your b with your d. They're both positive, 12. Over 4. Over 4, x is equal to 3. So find a spot, put 3 in the x spot. And then to find our corresponding value of y, you go up to the system and you pick either one of those equations. I'm going to repeat. You pick either one. It doesn't matter whether you pick number 1 or number 2. I'm going to go ahead and pick number 1, and I'm going to bring it down right here. X minus y is equal to 4. We just found a value of x to be 3, so we're going to substitute 3 in place of that x and rewrite the rest of this equation. We got to solve it for y, so the 3 is going to have to go opposite on both. We're left with a negative 1y, and if I were you, I would definitely write down a negative 1y literally, and that's going to be equal to 1. Over negative 1, over negative 1, y is equal to negative 1. Put that negative 1 right there. There's the solution to that system using elimination. Now again, what was nice about number 1, as soon as the system was written down, we noticed that the coefficients of y were opposite. And that is what you want to have, either with your x terms or your y terms. Now when we go to number 2, we're not going to see that situation. We're going to climb the ladder just a little bit. Let's go to number 2, and here it is. X plus 4y is equal to 16. 3x plus 5y is equal to 20. Number 1, number 2. Notice, they're both written in standard form. Look at the coefficients of both x and y. That coefficient is 3, that coefficient is 1. They're certainly not opposites. That's 4 and that's 5. They're not opposites. When you don't see opposites, you have to create opposites. You have to make opposites. And here's the key word. To create opposites, you have to bring in the operation of multiplication. Remember, you can do anything to an equation. You can add, subtract, multiply, or divide both sides by any given number, just as long as you do it to both sides, and you'll get an equivalent equation. Now here's the technique, so that we'll know how to deal with the multiplication. There's a key acronym that we've talked about in the past, and that acronym is called the least common denominator. We're going to put that least common denominator into practice in order to help us solve this system by elimination. Let's begin by looking at the coefficients of x. That coefficient is 1. That coefficient is 3. Would you imagine that this coefficient of 3 is in a denominator position, and this coefficient of 1 is another denominator? If we were going to identify the LCD for these two coefficients, 1 and 3, that LCD would definitively be 3. The LCD is 3. It just so happens that the coefficient of one of the variable terms of x is 3. So if we want to eliminate the x from this system, since this coefficient is 3, and our LCD that we came up with was 3, we're going to leave equation number 2 as it is. We would just come up to equation number 1, and we would decide what we're going to multiply both sides by so that we get the following. We want to multiply this x term by some number so that its result will be the opposite of a positive 3x. If we were to multiply x by a negative 3, negative 3 times x would give us a negative 3x, and that would be the opposite of that positive 3x. Now before we do that, let's go quickly over to the y's. Look at the coefficients of y. That's 4 and that's 5. The LCD between 4 and 5 would be 20. He's not 20, and neither is he. If we wanted to eliminate the y's from this system, we would have to multiply both sides of both equations by specific numbers so that the coefficient of this y term would become some kind of a 20, and this one would have to be its opposite. This would require more work to get rid of the y's than to get rid of the x's, because the LCD between 1 and 3 is 3, and he's already 3. So, we're going to eliminate the x's because there'll be less work. Let equation number 2 stay as it is. Go up to equation number 1 and tuck the left-hand side and tuck the right-hand side. Now people, down here we've got a positive 3x. I want to multiply both sides of this equation by a number that will accomplish something. Getting rid of my x's. He's a positive 3. I want him to become a negative 3x. If we multiply both sides of equation number 1 by negative 3, that ought to do it. Let's distribute. Negative 3x. Negative 12y. Negative 48. Draw a line. They're opposites. They're gone. Add the positive 5 with the negative 12. Add the positive 20 with the negative 48. You got to subtract. That'd be a negative 28. Over negative 7. Over negative 7, y would be equal to 4. Find a spot. Put that 4 in the y slot. And then come up and bring down any one of the equations. You can bring down the original number 1, the new number 1, the original number 2. I'm going to bring down the original number 1. You can pick any one of those 3. I'm going to bring down the x plus 4y is equal to 16. And we're going to use this equation to find our value of x. The value of y is 4. So x plus 4 times 4 is equal to 16. X plus 16 is equal to 16. Subtract 16 from both. X is equal to 0. Put that 0 up there. Got our solution. So what did we have to do with number 2? We had to bring in multiplication, but to only one equation. Only one. The next one, we'll have to do it to both sides. Here we go. 2x plus 15 is equal to a negative 3y. It's number 1. Number 2, 5x plus 2y is equal to 1. That's number 2. Notice, prerequisite, standard form. He's ready. Number 1 is not ready. He's not ready. We're going to have to get it in standard form. This x term on equation number 1 is already written directly above the x term of number 2, so let's just leave this 2x right there. We want to move this negative 3y over to the left-hand side, and we want to move that 15 back over to the right. So to move that negative 3y, I'm going to do it right here very carefully because I got limited space. If we go a positive 3y on the right, then we'll have to go a positive 3y on the left. We got to get rid of that 15. He's got to move over on the other side. So we'll go the opposite of that, negative 15 on both. Come on, put it on there. All right, now let's write this thing. 2x plus 3y is equal to a negative 15. They canceled. Got your 2x plus 3y on the left. Y's cancel over there. We've got a negative 15. Now we have these in standard form. I'll go ahead and stay with him with number 1. Now look at the coefficients of x. They're not opposite. The coefficients of y, they're not opposites. Let's go back to the x's and let's find the LCD so that we'll know what number we're going to have to use to get opposites. The LCD between 5 and 2 is 10. He's not 10. He's not 10. Let's move over to the y's. Let's identify the LCD for the coefficients of y. That LCD would be 6. Neither one of them is 6. So because neither one of these was 6 and neither one of these over here was 10, no matter which variable term you get rid of, you're going to have to multiply both sides of both equations to acquire opposites. When that happens, here's my suggestion to you. It's not a demand, it's a suggestion. I would always get rid of the front variable term. In most cases, I would get rid of the x. You tuck the left and the right of number 2, and you tuck the left and right of number 1. Now, it's as basic as this. I've made my mind up, I'm going to get rid of the x's. If you want to get rid of the y's, you go right ahead and do it. You'll do it in the same way as I'm going to do these x's. The LCD between 5 and 2 is him. So I'm going to start with this 5x term. I'm not looking there yet, I'm just looking at this 5x. What would I have to multiply 5 by to get some kind of a 10? Well, by golly, if we multiplied it by 2, that would give me a 10x. Now I'll stick another 2 right over there. Then don't do anything yet. Come down here to this x term. This one right up here gave me a positive 10x. This one right here is going to have to give me a negative 10x. The opposite of him. We're going to have to multiply the 2 by some kind of a 5 to generate a negative 10x. And that's going to have to be a negative 5. Now just hold it right there to make sure that we're right on course. There's 10. There's negative 10. That is exactly what we want. So now let's put that negative 5 right over there. And now let's distribute these two. 10x plus 4y is equal to 2. Let's distribute this one. Negative 10x, negative 15y, a positive 75. Draw the line. Let's add down. The x's eliminated. We had to make it so. They're gone. The y's, a negative 11y. Add these, 77. Over negative 11. Over negative 11. Y would be equal to a negative 7. Find a spot, put it there. Now let's find our value of x. I would not pick any of these. These coefficients are too big. You either pick the original number 1, your new number 1, or the number 2. It doesn't make any difference. This one in purple right here, let's pick him. He's right there. Any one of them will do. 2x plus 3y is equal to negative 15. Bring down the 2x, bring down that coefficient of 3. That 3 is going to have to be multiplied by the value of y, which is negative 7. He'll equal a negative 15. 2x, negative 21, is equal to a negative 15. Positive 21, positive 21. We'll get a 2x is equal to 6. X will be equal to 3. 3, -7. That ought to do it. Okay. Now I just want to quickly just look at this just to make sure that I haven't made a mistake right here, because I've done this problem, it seems like 1,000 times, and I just want to make sure that we haven't slipped up right here. Well, I can see that I did. But I'm not going to change it right now. When I moved him over, no, I was all right. -10x minus 15y 75. And I think we're okay. I think it's all right. Okay? I think it's good. Let me erase this thing and let's get this last one out of the way. (3x plus 4y) is equal to -6. (-2x plus 3y) is equal to 4. Now they're both in standard form. The coefficients of x and y are not opposites, so we're going to have to create them. Look at the coefficients of x. Don't disregard him for a moment. LCD would be 6. For the y's, 12. Neither are 12, neither are 6. I'm going to get rid of the x's. They're right in front. Tuck, 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 and tuck. LCD, if we're going to get rid of the x's, is 6. I need to make him some kind of a 6. This guy, it's opposite. 3 times 2. That's going to give us 6x. So I'm going to get a 2 right over there. This one, he's going to have to become the opposite of him. He's going to have to become a -6x. If we multiply by 3, 3 times -2 is a -6. That's +6 by 3. Got it. Back up here, distribute. 6x plus 8y, -12. -6x, +9y, 12. Draw the line. Add down. Goodbye. Hello. Hello. Over 17 on both. Y is equal to 0. Find a spot. Y is 0. Pick any one. One of these original. This is a good one. Either one of them. 3x plus 4y is equal to -6. 3x plus 4 times the value of y, which is 0, is equal to -6. 3x plus 0 is equal to -6. 3x is -6. Over 3 on both, x would be equal to -2. -2, 0 would be the solution. And that takes care of that last one. Now, folks, there's no doubt about it. It feels like I've done this problem 1,000 times. And you felt the frustration in my voice and this board and everything moving all over the place. Now, hopefully, we're going to be able to get this thing clicked and get it sent to you today. But we appreciate your time. That takes care of 5-3, and we'll talk to you soon. Bye.